Well, hey guys, I'm just going to work my way through some of these minimum standards practice questions, show you how I might have attacked them, give you some tips and tricks along the way. There might be more than one way to do these, but yeah, just going to give you an idea of how I might have approached them. In this question, we're going to find the highest score. So of this list, which is the highest number? Probably the best strategy that I would suggest would be just to start by looking at the first column, right? This is the highest digit in each of these numbers in the 10,000s column. And instantly you can see that there's only two of those scores that are in the eights for this one, or the 80,000s. So the beautiful thing about multiple choice questions is that we can often rule out a couple of options, and even if we've ended up got to have a guess after that, we've at least got it down to a 50% chance instead of a 25% chance. But we don't need to guess with this one, because I can continue to have a look at the next column, which is my thousands column, this second column here, and that doesn't help me because both of those numbers are a 7. They're both the same. So I'm just going to keep working my way along. Next, I'm going to look at the hundreds column, and I can see Dan's got a 7 there, and Marie's only got a 0. So the higher of those is Dan's, so his score is higher. So we just worked our way along from the left to right, and we worked out that Dan, answer A, is the highest score. In question 2, we're asked what combination of these shapes would make up this bag. Well, let's have a look at this. I hope you can look at this bag and realize it kind of makes the shape of I don't know, like a can of Coke or something on its side. It's what we call a cylinder. And a cylinder has a circle at one end. So looking at our list of options, that instantly, well, it means we definitely want to use, let's make that a bit neater. We definitely want to use A, because A is a circle. So that is definitely going to be used because it's like this bit on the end. So here's the beauty of multiple choice questions to help you. Having a look at our answers, I know, even if I'm not sure of the other shape, I know these two options, C and D, can't be correct because I know I need to have something with A in it, and it's only these first two answers that have an A. So even if I had to guess now, I'm down to a 50-50 chance. But I don't need to guess because a B and A would be the circle and this triangle. There is nothing on my diagram over here that looks like a triangle. So I'm going to go with this, A and C. In fact, I could check if you took I don't know, think of like a can of Coke, for example, or something that's got like one of those plastic labels on it, and if you then peeled that label off, what shape would you have? It would end up being a rectangle, which is this one here. So yeah, we've narrowed it down to A and C without even having to think too much about it because A and B just wasn't an option. But yeah, that's the answer to question 2. Question 3 here is kind of what we call a pictograph. It's a graph that's kind of made up of pictures, but the important thing is this bit here. Down the bottom here, a key. A key means that on a pictograph, it tells you what each image represents. It's not, in this case, each piece doesn't represent like one pizza. Like this doesn't mean one piece of pizza or one person surveyed. It actually means 5. So each one of those represents 5. So let's count them all up. And when I do that, I count that there's actually, if I counted up all these bits of pizza, I'd find that there are, in fact, oh, no, there's not. There's 20. Sorry. I wondered what I was doing. There's 20 pictures. Yep. So there's not 20 people surveyed because each picture represents 5 people. So it's 20 lots of 5. I don't think you've got a calculator for this question, so hopefully you'll be able to do 20 times 5 equals 100. If for some reason you couldn't do that in your head, you could do what we call additive thinking. So you could think, all right, well, that's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, which would make my answer C. So you could do 20 times 5, or if you were stuck with your multiplication in your head, just add it. Each one was 5, add that 20 times, and you'll get down to this answer. Question 4 involves us using some 24-hour time. Let's move that across so you can see it. And hopefully you remember 24-hour time is made up of 4 digits. So for example, 13, 15. The first 2 digits are the hours and the second 2 digits are the minutes. And when we get to 12 o'clock, so if we get 11 o'clock, 12 o'clock through the day, we don't go back to 1, we keep rolling on, etc., 13, etc. So, having a look at our question, Fred notices that it's 4:45 in the afternoon. So 4:45, I could write as 4:45 p.m. if I was writing it in 12-hour time. But he wants to see what that is on the timetable, but it's written in 24-hour time. So for anything after the afternoon, so after 12 o'clock, we simply add 12 to it. So if I've got 4:45, I'm going to add 12 to the hours to get 16:45, which is in fact our answer C. Okay, so that is written in 24-hour time. So to get from 12-hour to 24-hour, just add 12 if it's in the afternoon. So anything after 12 o'clock, so if it was 1 p.m., we add 12 to it, we would get 1300. All right, that's question 4. Question 5, which of these two temperatures are closest to each other? Now, the hard thing here, or the tricky thing, is negative numbers. They can get really confusing. So I would suggest even take a few seconds and just draw a number line. Now, a number line has a 0 in the middle, and off to the right we have the positive numbers, and off to the left we have the negative numbers. So I could draw in 1, 2, 3, 4, 5, 6 some positive numbers that way, and negative numbers going down this way. And it's pretty messy, but it's going to do the job for us, because I can visually now compare these two numbers and see which ones visually are closest. So looking at our first option here, -6 and -3, I could draw -6 and -3 is there. So I can see that they are in fact only 3 places apart. So I'm going to just put that there to remind myself that they're 3 places apart. Let's have a look at -2 and 3. So -2 is, whoops-a-daisy, let's fix that up. -2 is here, and so we're doing this one at the moment, and 3 is here. Well, I can see that they're much further apart, so I can scratch that one because we're looking to the closest. So the moment, question answer A is the closest one together. Let's try 2 and 6. So 2 is here, 6 is here, and I can see that they are 4 places apart. So once again, that one's not any closer than my first option. So let's have a look at the last one, -3 and 3. So I might do these underneath. -3 is here, 3 is here. Well, they're way further apart. In fact, they're 6 places apart. So my answer, the closest, is answer A. But just doing that little number line helped me to visually see this distance in here. All right, well done. All right, this is an interesting one because you're given a calculator and you can actually work this out by doing the calculations and working out the exact numbers. I'm going to do that option second. First of all, I'm just going to crunch it out in a slightly, not cheating way, but just utilizing the fact that it's a multiple choice question and trying to eliminate some of my answers. So let's think about this. The music clip is 4 minutes long. That means from the start to the finish is 4 minutes. So we've got 0 minutes here, 4 minutes here. I can see that visually it's been paused at that point there. I've got this red bar here showing me how far it's played. You guys are all familiar with sort of, that from YouTube and that kind of stuff. So before I do any calculations, let's think about this. Halfway through the video clip must be 2 minutes. That would mean about here, a quarter of the way along would be 1 minute, and 3/4 of the way along would be 3 minutes. All right? If it was 4 all up, I've just broken it into 4 even pieces. Now let's see if we can rule out any of our answers, knowing that our video has stopped somewhere around about here. It's definitely more than 1 minute, so I can scratch that. It's definitely less than 2 minutes, so I can scratch that. And well, if it's less than 2, then it's clearly less than 224. My answer is 136B. And I think that is, if I get it, yeah, that's the correct answer, B. Now, that is doing it without even having to use the calculator and just using the visual clues that we're given on the image. But let's actually do the maths for a second and show you if you wanted to work that one out mathematically. Minutes are kind of hard to work with because our answer has minutes and seconds. So I'm going to convert my 4 minutes to seconds. So it's going to be 4 minutes times 60 seconds is 240 seconds. So I'm going to work with seconds. Now, to get 1% of something, right? To get 1%, I divide it by 100. So I'm going to take my 240 divided by 100 equals 2.4 seconds. So 1% would be 2.4 seconds. We want, the question says 40%, so I'm going to take 40 times my 2.4, which gets me to 96. But remember, this is in seconds, so if I convert that to minutes and seconds, that's 1 minute 36 seconds. So I could have done it mathematically, use the calculator, and probably the easiest way with some of these percentage questions is divide it by 100 to work out what 1% is. That's what I did here. And then times it by however many percent you need. Two options there. I could have crunched it out just using the diagram or done the maths. Feel free to pause and rewind that if you need to review what was going on there with the maths. This is, question 7 is a distance time. So what that means is I have time along the bottom and distance up on my vertical axis. So all that means is as time passes by, so as I work my way along, does my distance increase? If I'm moving, then yes, it does. Okay, so if I'm, let's say I was in a car driving, as time goes on, my distance increases, doesn't it? Because I'm traveling. But if time goes on and I haven't moved anywhere, like these horizontal bits, I must be standing still. That's what the horizontal parts of this distance time graph represent. And really important, and guys, I can't stress this enough, is take some time just to read the question, because there are 2 breaks in this diagram. There's 2 times where they stopped. There's 2 horizontal pieces. So which one do we want? Well, the question says, on the way they stopped for a milkshake, and later they stopped for lunch. So this must be the milkshake, this must be lunch, because the lunch came after the milkshake. But the question says, which point represents the end of the lunch break? Well, if here was lunch, it looks like it finished here, so point C is our answer. Okay, so just a quick review of that. The horizontal sections of a distance time graph represent stationary, when you're not moving, right? Time is passing by, but the distance isn't increasing. And the rest of it was just making sure you read the question. Good job. Right, another kind of wordy with a diagram question. So just take your time, read it, have a look for clues. And here's the biggest clue in this one right here. This is a compass rose. Okay, it shows us the north, south, east, and west direction. So Corey just got off the bus on Main Street at the bus station. So here's the bus station, and he got off onto Main Street, because that's Main Street there. In what direction does he have to walk to get to the county hospital, which is down here? So if he's got off the bus here and he needs to walk down to the hospital, he's obviously going in this direction. And if I look at my compass rose, that direction points to east. Answer C. All right, one of the important things for question 9 is you're just going to have to know. It's just a fact of how many kilograms there are in 1.5 tons. Because if you have a look at all your answers, they're all listed in kilograms. Okay, but our question is in tons. So what's the conversion? Well, 1 ton equals 1,000 kilograms. It's just a fact you kind of need to know. So we're going to, instead of using 1.5 here, we're going to convert that. So 1.5 times 1,000 means I'm working with 1,000 5,500 kilograms. Okay, that's my total amount, and I want to work out 15% of that. Okay. Hopefully you remember in a previous question I said probably the easiest way is to get 1% first of all. So to get 1% of something, we simply divide it by 100. So let's take our 1,500 kilograms divided by 100, and we get, gives me 15 kilograms. So in other words, 1% is 15 kilograms. I want to know 15% So all I do is I take my 1% and multiply it by 15. So 15 kilograms times another 15 gives me 225 kilograms. So my answer is C. Once again, with these percentage questions, often the easiest thing is divide the amount by 100 to work out what 1% is. Right? In this case, it was 15 kilograms. And then you can say, all right, well, how many do I need? Multiply it by that. So I ended up with 15 times 15 to get my 225. All right, question 10 is one of those questions where there's kind of two ways you could approach this. One, where you kind of do understand the actual maths, and I'll do that second. Or another one where you can say, hey, this is a multiple choice question. Can I just crunch out some of the numbers and just brute force this to see which one it is? In this case, I'm going to do a bit of just a process of elimination, because for each of these, I'm just going to pick a point, right? A coordinate. So I'm just going to take this point here, the 1, 4, and I'm going to substitute them in and see which one works, see which one is true. So here's what I mean. Now, when I'm substituting, I like to put a bracket wherever there's a letter. Okay, so in this case, I've got t equals 3n plus 1. I'm just going to replace those with these values. A t value of 4. Okay, so where the t was, I'm going to put a 4. And when the n was, I'm going to put a 1. And I'm going to work that out. So that gives me 4 equals, 3 times 1 is 3, plus 1 equals 4. Right? That is true. 4 does equal 4. So I already know that's my answer. Okay, because if I took a point and put it in and it didn't work out to be equal, to be true, then it wouldn't be on there. So let's pick one at random just to show you what I mean. Let's take the bottom one here. So, all right, well, let's go with n equals 6t minus 2. So I'm just going to put brackets wherever there's a letter. And I'm going to replace it with the same coordinates. An n value of 1. So where the n was, I'm going to put a 1. And a t value of 4. So where the t was, where the t was, I'm going to put a 4. And I'm going to see what this gives me. Well, I've got 1 on the left-hand side. 6 times 4 is 24. 24 minus 2 is 22. There is no way that that is true. So that rule couldn't apply. Okay, so there was just a process of elimination. Substitute in, pick a coordinate, pick a pair and substitute them in to see if it is true, which this one was. That's how you could use the fact that it's a multiple choice question. Now, I'm going to undo all that. I'm going to erase all of that and just do it mathematically and see if we get the same result. All right, here's how we're going to do this one mathematically. First things first, this number on the bottom, or this letter on the bottom, is t. So my answer is going to be t equals something, okay? Because we take this one in the bottom left, what we call the dependent variable, okay? But it's usually the one on the bottom here, and it starts my equation. So instantly, I can see, because of a multiple choice question, these two get wiped out, which is awesome. Even if I had to guess now, I've increased my chances of getting it right. But we don't need to guess. I can see that these are going up constantly. Every time we've got a constant difference of plus 6. But when I look at the numbers up the top, they're actually skipping one each time, aren't they? So I'm actually going to fill them in and add in the ones that are missing. So now I've got 1, 2, 3, 4, 5, 6, 7 across the top. Now, that must mean these ones in between. If it was going up by 6 each time before, these intermediate ones, sorry, I got that wrong, are going up by 3. So that will go to 7, 13, 17. Okay. It's not 17, 19. Duh. Okay, so they're actually now going up by 3. That's important because this number now goes in front of my n. So the constant difference, in this case, the going up by 3 each time, is the number that goes in front of the n, and I can see that answer A has that 3 there. So that was the mathematical approach. You could have used either, so it was going to be 3n plus something. Don't worry about the rest. We don't need to know the rest. We could work that out, but for the moment, that gives us everything we need. I filled in the numbers across the top, so it was in order, 1, 2, 3, 4, 5, and I could see that my constant difference was 3. All right, fair bit in that one, but hopefully that made sense. All right, couple of options with this one, but they all depend on doing this one important thing first of all. You'll notice there's no calculator option with this question, so you're going to have to do this one. The other important word here is an approximate. So they're not asking you to work it out exactly, but an estimate. So I see two numbers here, 42 litres and 127 cents. They're, or 27.78. They're kind of ugly numbers to work with, but if I round them down a little bit or make them easier to work with, 42 is pretty close to 40, so I took it down a fraction. This one, if I took the other one down, I might want to take this one up a fraction to 130 cents. So I'm going to work with 40 and 130. So if the car has a tank of 40 litres and every litre is 130 cents, to fill it up, I multiply those together. So 40 times 130. Here's where you've got a couple of options of how you want to approach this. Depending on whether or not you can do this in your head, I mean, you could write out, let's do it this way. You could write out the algorithm, some of you might remember doing it this way. However, there's a little shortcut here, and here's the shortcut. Because both of these numbers end in a 0, I'm actually just going to cross those zeros out and put them aside for a second. Both of them. 2 zeros. I'm going to get rid of them. And so now what I'm left with is 4 times 13, which is much easier to do. I could do that using an algorithm. Right? 4 times 3 is 12. Carry the 1. 4 times 1 is 52. Or I could just say, well, 4 lots of 13, I could add them together. And if I add this first column, I get 12, so carry the 1. Either way, I get 52. So I've got 52 here and 52 here. Don't forget, bring the zeros back then. So the 2 that I took away, I now bring back. And this is cents, but my answers are all in dollars. So I just move the decimal point 2 places along from the end, and I can see that I've got $52. All right, now even if you forgot to bring these zeros back into play, once you got to this bit where you saw the 52s, that should be enough to make you think, oh, crikey, it must be my answer over here. All right, I rounded this one down a fraction, rounded this one up a fraction, and I worked with these numbers because they're much easier to work with. Good job. Getting question 12 right depends on you knowing one fact related to this word here. The median score in a set of data. Median means the middle. It's the one that's smack in the middle of our set of scores. Now here are our scores on this chart. So how do I know which one is the middle one? Well, I'm going to count how many there are, which will help me work out the middle. So I've basically got 1, 2, 3, this is score 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 17 scores. So if I've got 17 scores, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's my 17 scores. The one in the middle is going to have 8 on either side of it. If there's 17 all up, think about that. It's like a seesaw. I've got 8 on one side, 8 on the other side. There's 16. The one in the middle is my 17th one. So I'm looking on my scores over here to find where is the point just after the 8th score. So I'm going to start at the bottom. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. There's my 8th score. There's the point just after it. So this is the column that sits in. It's right there. And that's the thing I'm looking for, that score at the bottom. Well, the score of 2 has my middle score in it. So the answer to the median score is 2. Question 13 is kind of tricky. Edward is walking. Now this involves reading the question. I think I mentioned this earlier in the video. It's so incredibly important that you take some time to read the question. It says, Edward is walking in a northerly direction along Pitt Street towards Main Street. So you'll notice there's no compass rose on this one. So don't just assume that the top is north. Can't make that assumption. In fact, in this case, it's not the case. But the question gives us the clues. It says he's walking along Pitt Street towards Main Street. So that's the direction he's going. He's coming along Pitt Street towards Main Street. And it says when he's doing that, he's traveling northerly. So in other words, if I was to draw a compass rose, going that direction is north. So that must be my south. This must be my west. And this must be my east. Because it says when he's walking along Pitt Street in this direction, he's traveling north when he's going towards Main Street. Now that gives me what I need. From here, I can follow the directions in the question. It says, all right, when he reaches Main Street, he turns right. So he's going to get to Main Street and then head to his right, which is that direction. Then he turns left onto the next street. So he gets up here and he takes a left and then left again. So he takes another left when he gets to the next street. What direction will he be facing? So here's where we've got to in our little journey, this point down here. And because we built our compass rose earlier, I can see that that direction actually represents a westerly direction. Our answer is D. All the clues were in the question that allowed us to set up this compass rose so we could get an idea of which direction is which. Like so many of these questions, question 14 needs you to read the question, okay? So Shastri works for a grocer. She gets a $50 note from a customer. So someone's paid her $50 and these are the things that they're paying for. So we're going to have to work out the cost of each of these three items. The big point here to look out for though is we've got the prices for each thing per kilogram, but the actual weights are in grams. So you're going to have to know that 1 kilogram equals 1,000 grams. So we're actually going to convert these into kilograms before we move any further. So with your calculator, you would simply divide them by 1,000. Well, so let's list them out. The tomatoes, 500 grams is 0.5 kilograms. Right? And if you couldn't do that in your head, if you couldn't sort of put it together that 500 grams is half a kilogram, you could do it in your calculator. You could say, all right, well, I've got 500 divided by 1,000, and that will give you a half. That's what this is here. And the cost for those things is $3 per kilogram. So I'm going to do the 0.5 times 3. Then I'm going to go down to the next item on my list. 100 grams of mushrooms at $7. So whatever this is, it's going to be multiplied by 7. Once again, I could take my 100 in the calculator, divide it by 1,000, and that would get me 0.1 kilograms of mushrooms. We do it one more time now for the strawberries. They are at $10 a kilogram, and I take my 250 grams divided by 1,000, gets me 0.25 kilograms of strawberries. So these numbers here I've converted into these values here. Now I can go through and I can simply work out with my calculator what each one of those is. So 3 times 0.5 is 1.5. 0.1 times 7 is 0.7, and 0.25 times 10 is 2.5. Okay, I add these three up and I get 4.7, or in other words, $4.70, because remember this is the cost of these items. So adding those three purchases up comes to $4.70. She gave $50 note and we're asked to work out the change. It says what is the correct change they should give. Well, I need to take my $50 note, subtract the $4.70 of costs, and you could do that in the calculator and you're going to get an answer of $45.30, which is answer D, right? Be careful. Remember, the big thing we did here up front was that these are in kilograms, but these are in grams. So we needed to do these conversions before we could work out what each item cost. We added the items together and took it away from the $50 note that she gave us. Well done. All right, question 15 is a bit of a doozy, so buckle up. We're going to go on a little bit of a journey with this one. First of all, I'm going to show you the multiple choice, grind it out kind of trial and error method. And then I'm going to show you the actual pure mathematical way of doing it. Like I said, there's a few questions that, just because you've got multiple choice options, you could try each answer to see if it works. Let's do it that way first before we get pure and beautiful with it. All right, Stan's got an average of 80 across 3 tests, and then we're given some clues. He's got a maths mark, right? His science mark was 20 more than that, and his history mark was 5 less than it. So he's got a maths mark called M, a science mark of M plus 20, because whatever the maths mark was, it was 20 more than that for science, and whatever his maths mark was, it was 5 less for history. So let's utilize that. We're going to test each one of these scores. So if his maths score was 55, that would mean his science score would be 75 because it was 20 more, and his history mark would be 50 because it was 5 less than maths. Now let's have a look at that set of numbers. Remember, for an average, we add them together and divide by the number of scores. There's no way those 3 scores can give me an average of 80 because they're all under 80. Scratch it. We've eliminated that one. Let's look at the second one, 60. Well, if his math score was 60, his science score is 20 more than that, it would be 80, and his history mark would be 55, okay, because it was 5 less than maths. Once again, there's no way those 3 numbers can give me an average of 80 because only one of them is 80. All the rest are under, so the average is going to be under 80. Scratch that one. Even if I had to guess now, I've got at least a 50-50 option. Let's check the next one. Let's check 70. If maths was 70, science would be 90, and history would be 65. Now, just looking at that, that's a bit hard. I can't just automatically rule that out, but I could get my calculator and I could work it out because the average would be those 3 things added together and then divided by 3. And when I do that, I get, 225 when I add them together, divided by 3. That works out to be an average of 75, which is not 80. Scratch that one. Our answer must be D. All right, that was kind of the grind it out, try each number and see if it works option. Let's get pure, and I'm going to rub all of that out, and we're actually going to do it mathematically because it's kind of cool when it works. All right, let's think about this. He's got a maths mark. We don't know what it is, so like for algebra, for numbers we don't know, we can call it, give it a letter. I'm going to call it M. I know that his science mark was M plus 20. It was whatever the maths is plus another 20. It was 20 more. And I know his history mark was 5 less than his maths. I know that to work out an average, I add those scores together and I divide it by 3 will give me an average of 80. Ladies and gentlemen, we've just created an equation. And you guys, because you're superstars, have done work on solving equations. If I can solve this for M, then I can work out what his maths mark is. Let's have a look and see. I've got some like terms that I can tidy up on the top here. And remember, we can add and subtract like terms. So I've got M plus M plus M. That would give me 3 M's, right? I've got 20 and a minus 5. So 20 minus 5 gets me to 15. So I've tidied up the top. All the rest I haven't touched. I've got it down now to this part here. All I did was I added these like terms and I tidied up the numbers to get it down to this. Now, I'm trying to get an answer that'll end up being M equals something. So how do I get rid of all this other stuff that's around the M? Well, let's get rid of this 3 first. That's divide by 3, so when I bring it across to the other side, it becomes times by 3. So now I've got 3m plus 15 equals 80 times 3 is 240. How do I get rid of this plus 15? Well, when I bring it over to the other side, it becomes a minus 15. So let's do that. All right, if I bring that over, that becomes a minus 15 because I changed sides, I changed sign. So now I've got 3m equals 240 minus 15 is 225. And the last step now is divide both sides by 3. And I get m equals 225 divided by 3 is 75. So his math score was 75. Come on, you've got to admit, that was awesome. That was taking an idea, using some algebra skills, and getting to an answer. So look, you could use either method. Like I said, because it's multiple choice, you could crunch it out like we did in the first part, or you could get beautiful and actually do the maths. There was a lot in that, I know. I'm speaking like it was dead easy, but it wasn't. So feel free to take some time and just work through that, pause it as we go, and or grab your teacher if you would like that a little bit further explained. All right, we've got 2 to go. All right, possibly one of the challenges with this one is to visualize what's going on. So let's see if we can actually draw it out. We've got a room, and my dimensions might look weird, but we'll see how we go. We've got, it's 4 meters one direction, 5 meters another direction, and 3 meters high. This is a prism, okay? And we want to work out, we're going to paint it. So we're actually not painting the volume. So I'm not going to work out the volume. I'm trying to work out the surface area. And then what we're going to do is, after we've worked out the surface area, if we were painting it, without any doors or windows, then we're just going to subtract from that the area of the door and the area of the window. Now, hopefully you remember with surface area, one of the easiest ways to do this is to draw out a net of what it would look like if I opened up this room and laid it flat. So I've got 4 by 5 on the floor. This wall is going to be 3 meters high. This other wall is 3 meters high, so it's 3 meters that way. And then I've got the other walls at the other ends. So that one's going to be 3 meters high there. That one's going to be 3 meters high there. Can I work out, now, hang on, do we paint the floor? Let's have a look. The walls are to be painted. All right, important. Very important when we read the question. We're not painting the floor, and we're also not painting the ceiling. We're only painting these bits, the walls. So imagine like I've kind of flattened the walls out. We need to paint those bits. So we can work out the area of each of those pieces now that we've got some dimensions, right? Because that's 5 there, that was 4 there. So this bit is 3 times 5 is 15. This piece is 3 times 4 is 12. This piece is 3 times 5, which is 15. And this bit is 3 times 4, which is 12. If I add all of those bits together that I've put in the circles, I've got an area of 15 plus 12 plus 15 plus 12. If I add all those together, I get 30, I get 54, and it's meters squared, okay, because it's an area, it's a surface area. All right, now I've got a figure now for the walls, but I have to take away the doors and the windows. Now, I've just noticed I nearly made a mistake. There are, in fact, 2 windows at 1 times 1.5, all right, times 2 of those. And there's a door, a single door at 1 times 2.5. So let's work out the area of those pieces. 1 times 1.5 times 2 gives me 3 meters squared worth of window space. And this is 2.5 meters squared of door space. Add them together. I've got to take away 5.5 square meters because I'm not painting the doors or the windows. So I'm going to subtract that from my 54. And that gives me an answer of 48.5, which is answer A. So I'm painting 48.5 square meters of space. Okay, hope that made sense. All right, with question 17, look, kind of similar to a question that was like 1 or 2 questions ago. There's a multiple choice grinded out kind of option, and then there's an actual pure maths option. So let's do the grinded out option first of all. We know that over 3 tests, Michelle has scored 70 on average. So if I took 3 lots of 70, I could say that over those 3 tests, she scored 210. Now that number becomes important because I'm going to test trial and error every one of these. I'm going to add 210 to it because it's like they're the marks that she scored on the previous 3 tests. And then I'm going to work out the average for each of these. So if I do 74 plus 210, that gives me 284. And I'm going to divide that by 4 because it was the first 3 tests plus 1 more test where she scored 74, and see if I get an average of 74. And you've got a calculator to use for this one. So I go 284 divided by 4 gets me 71. That's not going to cut it. Let's keep trying, and we got 288. I'm going to divide that by 4. I get 72 as the new average. Nope, that's not going to cut it. I've got 292 when I add these together. Divide that by 4, and I get 73, so that's not going to cut it. I see a pattern forming. I'm going to assume that my answer is going to be D, but let's just test it. I'm going to go, that gives me 296. Divide that by 4, and I get an average of 74. Bingo, that's the one we were looking for, all right? That was the trial and error, because it's multiple choice, grind it out kind of option, but there is a more pure mathematical way. Let's have a look at it. All right, we know that for the first 3 tests, her scores add up to 210 because she averaged 70 over 3 tests. So 3 lots of scores of 70 gives me 210. We know that if she does 1 more test, her average will go up to 74. But I don't know what that is, so I'm just going to call it X. Remember, in algebra, for a number we don't know, I know that the 210 she got for the first 3, plus the next score, when I divide all those by 4, because now she's done 4 tests, I'll get an average of 74. Hope you can see it. I've now got an equation with 1 unknown, and you guys can use your algebra magic to solve this. Let's do it. I take my divide 4, when it goes to the other side, it becomes a times 4. Okay, it becomes the opposite thing. Divide 4 becomes times 4. So I've got 210 plus X is what I've got remaining here, equals 74 times 4 is, going to be lazy and do the calculator because you've got a calculator for this one, 296. Finally, the last step, because I want to get an answer that says X equals, I take my positive 210, change sides, I change sign, and now I'm left with X equals 296 times minus 210, which gives me 86. So this extra 4th score, the one we didn't know that we called X, has to be 86. Good job, wonder. All right, here is the last one. 18, question 18. All right, so I've got a ratio, I've got a scale of a map to real life. So 1 centimeter in real life, 1 centimeter on the map would equal 100,000 in real life. And I like to put a little comma in here because sometimes these zeros get a bit blurry together. So I know I'm working with 100,000, not a million. So this is on the map and this is in real life on this side. It's like a comparison of the two. So you don't have a calculator available for this one. So we're going to have to, I'll give you a few tips as we go for multiplying these out. So I'm going to take 1 centimeter and I'm going to multiply it by 2.6 to get my 2.6 centimeters, okay? Because that's what we're told on the map, it's 2.6. That means I've got to multiply this side by 2.6. How do I do that if I don't have a calculator? Well, because this is a decimal, I can add as many trailing zeros after the 6 here as I want. There are 5 zeros, so I'm going to move my decimal point 5 places. 1, 2, 3, 4, 5. There. So I've got 260,000. So 2.6 centimeters on the map is 260,000 centimeters in real life. However, if I look here, none of these options are in centimeters. So I'm going to have to do some conversions to meters and kilometers to compare them. How do I convert 260,000 centimeters to meters? Well, there's 100 centimeters in a metre, so I'm going to chop off 2 zeros. Okay, I'm going to divide it, effectively I'm dividing by 100. So now I've got 2,600 metres. Right, no, none of them are those answers, but I can rule out those two because the answers that have metres in them are not 2,600. How do I convert this into kilometres now? Okay, well, there are 1,000 metres in a kilometre, so I'm going to move or divide this by 1,000. In other words, to do that, I move the decimal point 3 places and I get 2.6 kilometres. The answer is A. I hope you guys got something out of that. There was some pretty funky maths. We went through it pretty quick, I know, but look, you can pause it, rewind. That's the beauty of technology. Or you can grab a teacher and just say, hey, can you walk me through this solution to help me understand? So yeah, make the most of it. Good luck with your minimum standards. You guys rock. Well done.